Okay. Told you about the math team. They're meeting twice a week on Fridays at noon and Mondays at 3 on the Birmingham West Campus in C100. That's the Science Building, C Hall, Room 100. Ms. Grassi is the coach, and she, one of the students in my yesterday morning's class, is participating. He said they're really having a lot of fun and learning math really well. So there's lots of advantages to participating. She's always looking for people to participate. Give it a shot. I've told you about the tutoring available on both campuses. On this campus, we have both student support services down the hall here, and then downstairs from there, the Space Center. Have the same type things on the Birmingham campus. In addition, they have the STEM lab that does some tutoring as well. So, two things. Number one, take advantage of it if you need it. And number two, consider being a tutor. Many of you are really good at math, I can tell so far. And if you have a A or B in any level math course behind you, you can tutor that math course here. So, take advantage of it. They pay fairly well, right? At or a little above minimum wage, I think. So please take advantage of that. Now, the one last announcement that I need to make is normally on Fridays, actually it doesn't feel like it, normally on Fridays I do have office hours on the Birmingham West Campus in B112. That's Dr. Pruitt's office. I'm in the copy room behind the secretary's desk. Usually Friday mornings from 7:45 to 11:45. Now, last Friday I had a treatment. Friday before I was actually there, and then 3 Fridays before that I had treatments or other things that. So I haven't been there often. This Friday I'm not going to be there either because I have my annual physical with another doctor at the Kirkland Clinic at Friday morning. So I won't be there then. I may, if the appointment gets over with on time, I think they've called some sort of meeting Friday, I don't remember what time, but if I through with my appointment in time to make it to the meeting, I may go for that. But again, I won't be in the office, I'll be at the meeting. So, but I might be there for just a few minutes. Okay. Any questions on anything we've done so far? Okay. Fred stopped me coming in to ask about making up. He was at a game Thursday when we had the test. If you did miss the test and need to make it up, you'll need to see me sometime during my office hours. Fred and I worked out for tomorrow afternoon shortly before 4 o'clock. Now, Fred, I've got a class here that ends at 3:15, so exchange materials. Huh? On Wednesdays. Yeah. They end at 3:15, so I get my stuff together and then leave, so I barely have 30 minutes to get over there. So I'm not always there much before 4, but I will be there a little before 4 or right at 4, depending on how traffic goes. But I can set you up in another room. Okay. So we'll work out whatever. If you need to make up the test, see me and we can do that. All right. No questions? All right. Now, review just a little bit. We went through this last time. This is a definition of a quadratic function. Okay? Now, in this definition, your A, B, and C could be any real number in the world. Okay? That could be positive numbers, negative numbers, fractional numbers, decimal numbers, rational numbers, or irrational numbers. It doesn't matter. Any real number. The only exception is A cannot be 0. Because if A were 0, that would not be a quadratic function, would it? It would be a linear function because the maximum exponent is 1. So A can't be 0, so it can be any other real number. Then this would be a quadratic function. F of x equals AX squared plus BX plus C. Now that looks like the old standard form for a quadratic equation. Shayla's here. Okay? The standard form for a quadratic equation would be this equals 0. Okay, remember that's what we did, based our quadratic formula on, and factoring, and all that kind of stuff. This was standard form for a quadratic equation. Now this is not standard form for a quadratic function, it's just a form for a quadratic function. We'll talk about the standard form later today probably. Now the graph of a quadratic function is a special type, and I think we talked about this last time, didn't we? But we just didn't get through with it. A special type of a U-shaped curve called a parabola. I really don't like the term U-shaped because, see, a U goes straight up here. Parabolas always are spreading out, always. What they're talking about is rounded at the bottom. They wouldn't say V-shaped, they spread out, but they're pointed at the bottom. So they say this. So it's sort of a mix between a U and a V. It's rounded at the bottom and spreading out as you go up. And Melva decided to show today. Okay. All right. Good deal. Okay. And that shape is called a parabola. I think we were talking about this last time. Lots of things that you run into in nature are in the shapes of parabolas. Really real life applications, okay? They mentioned a couple here. One of the features and characteristics of a parabola is a parabola has a point inside that parabola, that curved shape like this, called a focus. And we don't talk about it, we're not going to deal with it, but in physics you do deal with it, okay? What that focus is, and this is kind of strange, but it's absolutely true. If you put a light source or any kind of source right at that focus, I'm going to use light because it reflects and you have a reflecting parabola, then the rays come out parallel, okay? That's what your flashlight does. That curved silver shape, that's a parabolic shape. Your headlamps on your car, if you look behind the glass, there's a curved mirrored shape, that's a parabola. They put the bulb right at about where the focus is, and then the beam of light comes out fairly close to parallel. Now it's not exact because your bulb is not a point source, okay? It's not, the focus is one single point, the bulb takes up more than one single point. So there is some spreading of the light. That's what it is. Now, going the other way, if any of you have DirecTV, Dish TV, any kind of your satellite dishes, it's a curve, right? That's a parabolic curve. And that receiver sits in it, sits right on the focus. Now, in that case, the satellite is somewhere out there, and it's in a fixed place, so they aim it straight toward the satellite. The beams coming in from the satellite, since the satellite's so far away, come in very close to parallel. When they come in parallel, they get reflected right toward the focus. So the receiver's sitting there right on the focus, so it's getting all the beams that are coming in, reinforcing, and that's how you get a signal. Okay? So all this, these are examples of parabolic shapes. Okay? Now, other things that you probably are a bit more familiar with. Now we have one baseball player and a couple of basketball or volleyball? Basketball. Okay? Every throw that you make in baseball or basketball, every shot you take in basketball is a parabola. It goes up and comes down. And that's a parabolic shape. Every throw, even when you're throwing the second to get the guy trying to steal, you think you're throwing a line drive? No, you're not. It is falling. Gravity is always pulling that ball down. Okay? That's why the pitcher's mound is elevated a little bit. Because no matter how hard he throws, gravity is going to be pulling it down. Okay? So those are all parabolas. Okay? So Parabolas are all over. Golf shots, tennis shots, anything is a parabola. Okay? Now, all parabolas are symmetric with respect to a line called the axis of symmetry, or the line of symmetry. Okay? We often just call it the axis of the parabola. And by the way, the focus is somewhere on that axis, but we're not going to talk about the focus now. Okay? The point where the axis intersects the parabola is the vertex. It's either the lowest point or the highest point on that parabola. Okay? Either the minimum or the maximum. Okay? The axis of symmetry goes through that vertex. Now, this is the form that we just talked about for that quadratic function. F of x equal ax squared plus bx plus c as long, okay. Remember, a couldn't be 0. If a is positive, that means the parabola is going to open upward. If a is negative, remember it can't be 0. If a is negative, that means the parabola is opening downward. So the leading coefficient, a, number 1 can't be 0, and secondly, the sign of it tells you whether it's opening up or opening down. And you see, in reality, if a were 0, then you would have a flat line. The smaller a is, closer to 0, the wider and broader that parabola is, until the limit when it's equal to 0, it's going to be a straight line. And then from there, if it's negative but very small, it's going to be very broad. And the bigger it is negative, then the tighter it gets. Okay? So the leading coefficient tells you which direction the parabola is opening. Make sense? All right. When the leading coefficient is positive, the graph of fx equal ax squared plus bx plus c is a parabola that opens upward. When the leading coefficient is negative, it's a parabola that opens downward. Now, here's the simplest type of a quadratic. It's not quite the simplest. The very simplest is when a is equal to 1, right? That was just called the squaring function. Okay? Next simplest is if all you have is an a there. And again, if the a is positive, it's opening upward. The closer to 1 is standard. If it's greater than 1, it opens more rapidly. I mean, the curve up is greater. If it's less than 1 but still positive, then it's opening more broadly. And same thing when it's negative, a very small negative number is opening broadly, and when it's negative 1, it opens sort of the standard way, and then any very large negative number is going to be a very tight parabola opening down. So there's your standard, or the simplest, one of the simplest forms of a quadratic function. Okay. So the graph of that parabola, because it's f of x equal ax squared, when x is equal to 0, y is equal to 0. So 0, 0 will be your vertex. Now, if a is greater than 0, it's going to open positively from there, upward from there. When a is negative, it'll open downward, but it'll still have a maximum. In this case, it's a minimum 0, 0, there it's a maximum 0, 0. Same thing we did before, they just lost the bx plus c. Okay? That's one of the simplest forms of a parabola. So, obviously, the bx plus c takes you off the origin, moves it around, but they're still opening up or opening down. Now, the a tells you something. It tells you what direction it's opening and how tightly or broadly it's opening. Okay? B and C tell you almost nothing. Okay? So that's why we don't really like that other form to be our standard form. Well, let's do this first. When sketching the graph of a simple parabola, quadratic equation function, it's helpful to use the graph of y is equal to x squared as a reference. Okay, so now the very thing I was talking about of broad or tight, that's what they're going to do. Start with the squaring function, y is equal to x squared, the parent function. Okay? Now, starting with that, in fact, we'll graph that first. And if you haven't noticed yet, this author loves graphing, okay? It really helps you see the math, not just talk about the math. Okay, so I'm going to get my pen set up. There we go. And because I see that both of our coefficients here are positive, I'm just going to deal the upward part of a parabola. Okay? That's all we're going to have. Things above 0. Okay? Now, how do we know that? Because no matter what value x is, positive or negative, you're squaring the x. And what is square root of either positive or negative number? Positive. Okay? So your y is always, and then you're multiplying it by positive numbers. So a positive number times a positive number is always positive. So your y's are always positive. I'm not going to worry about anything down there. Okay? So let's first graph y is equal to x squared. Okay? Now we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, 2, 3, 4, 5, 6, 7, positive 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Give me a few points of y is equal to x squared. 1 what? 1 would be a good x value. What would your y be? 1. 1, 1. Okay? Repeating yourself. Okay? Another one? 0 what? 0, 0. Repeating yourself again. 2 what? 4. Okay, that would be somewhere about here. Another? Gavin's here. Okay, another? Second? 3. 3 would be what? 4, 5, 6, 7, 8, 9. There we go. Can't go any higher because we're running out of room vertically. So where could we go? Negative. Give me a negative number. Negative 1 would be what? 1. Negative 2 would be 4. Negative 3 would be 9. There we have it. There is our parabola. Now looky here. Sure enough, it's symmetric. What's your line of symmetry or axis of symmetry here? The y-axis, because that's where your vertex is, right there. Okay? So our graph of this will be like this. Now, when you're drawing parabolas, always make sure they're rounded at the bottom. That one's a little pointed. It's just because I don't draw too well. But always make sure they're rounded at the bottom. Never pointed. Okay? So, pick me a color for F. Red? Okay, we're going to do F in red. Now, what is that telling you? How does that compare to this? What? It'll be wider. You're absolutely right, because you're multiplying this value by 1/3. Well, that value is a y value, so therefore you're taking 1/3 of all your y values. So we've already calculated the y's here, so let's just take 1/3 of it. What's the y value of this one? 0. And what's 1/3 of 0? 0. Okay, that one's going to be right there. Okay? What's the y value of this point? 1. 1/3 of that is 1/3. So it's going to be down there. You're absolutely right. It's going to be wider. Okay? What was the y value of point? Whoa! Goodness gracious. This chair has a thing on it that adjusts the seat that I never use, but the handle loves to grab the line there. Let me make sure my pen's, yes, it still works. Good. Okay. All right. What's the y value of this point? 4. What's a third of 4? Hard math, huh? Fraction. It's 4/3. And 4/3 is how much? 1 1/3. So that will be 1 1/3. Same x value, but now we'll just do 1 1/3. That would be somewhere about here. Okay? And the Darius is here. Yeah, fine. There you are. All right. Anyone else come in since the call draw? Okay? What was the y value of this point? 9. What's a third of 9? 3. So we'll come down and that one will be 3, 3. Right about there. Okay? Same thing on the left. A third of 1 is 1/3. A third of 4 is 1 1/3. And a third of 9 is 3 again. Okay? Now we could do more points out there if we wanted to, but I think you got, well, let's just do a few. 4 squared is 16. 16/3 would be 5 1/3. 1, 2, 3, 4. 5 1/3 would be over 4 and over -4. Okay, something about like that. And then that was 4. 5 would be 25. A third of 25 would be 25/3, which would be 6 1/3, right? Wait. No, 8 1/3. Okay? 1, 2, 3, 4, 5, 6, 7, 8 1/3. Okay, I think this is as far as we're going to be able to go with it. Somewhere there it's the same color, so it's hard to tell. But anyway, here is our curve. This one's a little bit easier to get smooth at the bottom. Okay? So there's your F. What color do you want to do G in? Pick a color. Say again? Green. Green? Is that what I heard? Okay, we'll use dark green. Here, we go back to our parent function, our squaring function, and that y value we're going to multiply by 2. Well, here, what was the y? 0 times 2 is 0, so that's still going to stay there. This one over here was y value was, can you see? Yeah, that's 1. 2 times 1 is 2. And -1, the value was 1. 2 times 1 is 2. Okay? Then go over here to 2. Its value up here, y value is 4. 4 times 2 is 8. That would be up here. Okay? And this one over here, -2 would also be 8. And that's right there. Can't go any higher, so here's how this one goes. Hard to get that one nice and smooth and rounded at the bottom. There you have it. So you see, a multiple of 1/3 is going to spread it out, and a multiple of 2 is going to stretch it. Y'all remember those little toys that used to be the arms and stuff, and you pulled the string and then the arms went up? That's what you're doing here. When you have a large number, you're pulling up, and you have a small number, you're letting them go down. So that would be small coefficient. If you flip these over, and those were negative, then the -1/3 would be the reflection of that red line, -1 would be the reflection of the blue line, and then the -2 would be the reflection of the green line. Again, stretched. Does that make sense? All right, so that was example 1. Should have circled, whoops, yeah. G was green. That makes sense. G was green. All right. Just turn 2 pages. All right. Let's see how the book did these. I'm going to erase mine. Okay, to erase it. Everybody got it? Okay. So they started with the parent function in gray, y is equal to x squared, and when they multiplied by 1/3, that flattened everything out. So 1 is 0, 0, still 0, 0. 1, 1, and minus 1, 1. We're now negative 1, 1/3, and positive 1, 1/3. 2, 4 was up here, and this then became 2 4/3, which would be 1 1/3 here, and 1 1/3 there. They didn't draw as big as I did. Okay? So it shrinks it by a factor of 1/3. Shrinks it vertically. And that's what we talked about before. Okay, the B part is going to take that same parent function, y is equal to x squared in gray here, and now you're going to multiply by 2, which is a vertical stretch. Okay? Every value is doubled. 0 doubled is still 0. 1 doubled is now 2. 1 doubled here is now 2. And 2 here, which is 4, is doubled, and it's 8. So that's going to be way up there. Okay? That's what happens when you multiply by a number greater than 1. Any questions? Okay. In that example, example 1, note that the coefficient A determines how wide the parabola opens or how narrow it opens. When the absolute value of A is small, something between 0 and 1, the parabola opens wider than when absolute value of A is large, something greater than 1. Then it's going to be a narrow stretch, vertical stretch, as opposed to a vertical shrink. We know that the graphs of y is equal to f of x plus or minus c is going to be a rigid transformation. What kind of transformation will this be? It's going to be a horizontal shift. If that's a plus, you shift to the left. If it's a minus, I think there's 4 people at home that's here. Okay. All right. If it's a negative, it shifts to the right. What about this one? Y is equal to f of x plus or minus c. What's that? Okay, it's a vertical shift because f of x is y, and you're going up c or down c from y. So it's a vertical shift. This is a horizontal shift, vertical shift. In this case, the plus goes up and the minus goes down. With the y's, things go in the right direction. This one is called the what? When you negate the x, what was the x here, when you negate it, it goes over here. The same function, but it goes on the opposite side. So that's a reflection across the y-axis, and this is a reflection across the x, because f of x is y, and if it was up here, and then you negate it, it goes down here. Or if it was down here, you negate it, it goes up here. That's a reflection across the x-axis. And that's exactly what having a negative a does. It flips it across the x-axis. Those are all rigid transformations of the graph y is equal to f of x. We did those in the last chapter. What was that? Around 1.6 or 7, somewhere in there. 1.6, I think. Can't remember for sure. Maybe 1.5. Not. Okay. So, for instance, in these figures, notice how the graph of y is equal to f of x, that's the gray graph, right there, can be transformed to produce graphs of other things. So here's a f of x equal negative x squared plus 1. What 2 things do you see happening to that? 2 things you see happening. First, you negate that. And what does that do? flip it across the x-axis, okay? Because you're negating the y. So what was a positive here becomes a negative here, okay? But then the next thing you do is, this is your y, you add 1 to it, so you raise it up. So when you flipped it, this one was down here, that's the reflection across the x-axis, and then the plus 1 jumps it up 1 unit, okay? So most of the time, that's how I like to do it. Start with the x and do the thing, flipping first, then the add. It really doesn't matter, but I usually find it works better that way. Okay, what's this one doing? Doing to this, huh? Horizontal, which way? How much? 2. No, this is vertical. Okay. Horizontal's 2. Which way? To the left, because it's always backwards. Okay. So you go 2 to the left. Here's your original. The y is equal to x squared, the grade, just like we had before. This is going to shift 2 to the left and down 3. There you have it. So this very shape, rigid shape. The shape stays the same. It just gets transported left and down. Okay? And then everything else. So its new axis of symmetry is what? X equal negative 2. Now here's a hint. Okay? And Monica didn't. Okay. I made it rhyme every time. Okay. All right. If you want to know the axis of symmetry, find the vertex. The axis of symmetry is going to be x equal whatever that x value is. X equals 0. It's the axis of symmetry for that one and this one. X equals 0. The y-axis is 0. Axis of symmetry. Same here. Find the vertex, 0, 0, whatever the x value is, 0. Here, the x value is negative 2. Axis of symmetry, x equal negative 2. Every time x equals that is going to be your axis of symmetry. Whatever your vertex is, find the x coordinate and say x equal that. That will be your vertical line that goes through it. And they usually do the dotted red line through that, unless it's on the axis, and then they don't put a dotted red line on top of it. I guess the typesetters can't do that. I don't know. So, make sense? Yay or nay? Good morning, Vietnam. Okay. All right. Now let's go to the standard form. I've been talking about this. The standard form for a quadratic equation is ax squared plus bx plus c is equal to 0. Why? Because we factor that. We use quadratic formula. We use the a, b, and c in quadratic formula. Yeah, it's very handy. However, that's not handy and useful in the standard form for a quadratic function. Now, if you go back to linear equations, okay, if you had a linear equation in 2 variable, I never liked it, but they always said the standard form, let me go back to dark color here, okay, was ax plus by is equal to c. Okay? There's nothing special about that, but they always call that the standard form of a linear equation, right? But it doesn't help you. It doesn't give you anything. What I like is the standard form for a linear equation. Anyone might want to make a guess? You can always transform these. Was this form? Y is equal to, anyone give me a help? mx plus b. I like that form because guess what? I can look at that and picture exactly what that line looks like. What does b tell you? Say again? Y-intercept. No, m is the slope. B tells you the y-intercept. If it's positive b, it's somewhere up there. Negative b is somewhere down here. And the slope, if it's positive here, negative there. You have a really good idea of where Chris is. I mean, where the intercept is. Okay, Chris is here. There you are. All right. Okay. So even though they call that the standard form, I like that one better because it tells you way more. See, the A, B, and C tell you almost nothing in the top form. The M and the B tell you everything you need to know in the other form. So our standard form for a quadratic function, we don't want an ax plus by plus c equals c. That doesn't tell you anything. We want the form that tells you something. The ax squared plus bx plus c, the a tells you a little something, the b and the c tell you almost nothing. So, what is the standard formula for a quadratic function? Here it is. F of x is equal to a, does that sound familiar? Same a as we had before. A, but rather than b and c, now we do x minus h squared plus k. Now that looks a little more complicated, doesn't it? But guess what? The hk is exactly the most important point in that parameter. The vertex. Okay? Just like y is equal to mx plus b, m's the slope, b's the y-intercept. You know those, you can plot the thing without even picking points. You can just plot. This one, you can start the process by plotting hk. Now remember, what follows the x is minus h. So if that was a plus there, the h is a negative number. If this is a minus here, the h is a positive number. What follows out here is whatever sign it is. Remember, the x is always backward, the y. That's the x coordinate and the y coordinate of the vertex. That form is especially convenient for sketching a parabola because it identifies right there your vertex. Okay? HK. Again, the opposite of what you see here and exactly what you see there. HK. So here's the standard form for a quadratic function. Quadratic function, f of x equals a times x minus h squared plus k. Again, a cannot be 0 because if a were 0, this would not be a quadratic. That would be f of x equal k. That's just a constant function, not a quadratic function. So this is what we say is the standard form for a quadratic function. Not the ax squared plus bx plus c. That was for an equation. It's a times x minus h squared plus k. The graph of f is still a parabola whose axis is the vertical line, x equal h. Remember? That's what you do. The axis of symmetry is x equal whatever the x coordinate is of your vertex. The vertex is the point hk. That's exactly why we did it. And still that a, same a as we had before. If it's positive, it's open upward. If it's negative, it's open down. Okay? That part is the same as before. But remember we said the a told you something. The b and c told you nothing. Here the a tells you the same thing. The h and k, which takes the place of b and c, they tell you everything you need to know, or a lot more of what you need to know. Okay? So, to graph a parabola, it's helpful to begin by writing the quadratic function in standard form. Now, what do we use to do that? Our good old method of completing the square. Okay? Remember, we did that for solving quadratic equations before. It was a little tedious and messy, but it still worked. But then once we got the quadratic formula, we never used it again. Okay? And at the time I said, and you all have to do this anymore until later. Now we're at later. Okay? Now we're going to do this in example 2. In this example, notice that when completing the square, here's the technique, and we'll go over this. You add or subtract the square of half the coefficient of x within the parentheses instead of adding the value to each side of the equation. Now that's a lot of blah, blah, blah until you do it. So let's do it. Sketch the graph of this, okay? But what we want to do first is write it in standard form. So remind me of what standard form looks like. F of x is equal to, remind me of standard form, a times x minus h squared plus k. Perfect. Okay? Now guess what? The A up there is the same as the A here, and what's your A here? 2. Okay? So that's where we're going to begin. All right? And here's how I'm going to do this. F of x is equal to, and I'm going to do something first, sort of like what they've done too. I'm going to separate the terms that have x's in them from the constant term. Get that way out there. So here's how I'm going to write this. Now this is gory detail. I usually don't take this many steps. All right, this is 2x squared plus 8x plus 7. Okay? I just separated them. Okay? Same thing, it's just got a lot of space in it, right? Okay. Now I'm going to factor out the a because up here the a is factored out. So that'll be f of x. So I'm just going to factor it out of those first two terms. That will equal 2 times what? X squared plus 4x blank plus 7. Okay? Notice that loud and obnoxious blank. Okay? That's what goes there. Now, here's the point where we use completing the square. Okay? Does anyone remember how that goes? Okay. Let's back up and think through a binomial. Give me a either a number, a letter, anything you want to give me. A combination of number and letter, I don't care. Just give me a letter. X, okay, now don't confuse it with this X, okay? X. What's that? Second? A? Okay. I really don't like A because I'm using A up there too, so give me a different one. K. We've got a K up there. Get something we don't have. P. Is that what I heard? Okay. All right, we'll start with P then. Now I need a plus or a minus. I don't care which. Second?
Plus.
Plus, okay. Now give me a number. 8, okay. Now I'm going to take P plus 8, I'm going to square it. How do I do that? What's that? You mean FOIL? Okay, yeah. We could do it that way. P plus 8 times P plus 8, right. That's what squaring means. Multiply it by itself, right? So let's FOIL it. And what do we get? First is P squared. Outer is plus 8P. Inner is plus 8P. And last is plus 64. And then what do we do? Combine like terms. That would be P squared plus 16P plus 64. Okay. Now I like this one because you get a happy face, don't you? Okay. Okay. That's beside the point. Here's a shorter way to do it without having to FOIL it and write it out and stuff. You square the first term, twice the product of the two terms, right? And then square the last term, right? Now we're going to undo that, okay? We've got the beginnings of a trinomial. That's why the blank is in there, okay? Beginning of the trinomial. The first term is squared, okay? And then rather than doubling the product of these two, we're going to take half of the product. Half of what's here. What's half of 4? 2. Okay? And then we're going to square that. Okay? Because half of 16 is 8. Square that, you get 64. So what we're going to do here, take half of 4, 2, and then square 2 is 4. So I just changed the problem, didn't I? Yes, I did. What did I do? I added 4 here, but I also multiplied that by 2, so actually I added 8. Not good. unless you subtract 8 over here. And that's exactly what we're going to do. We're going to, because you added 8 here, we'll subtract 8 here. Now we haven't changed the problem any, have we? We have exactly the same thing we did before. Okay? But what we have now is 2 times, and what's this a square of? X plus 2 squared. And what does plus 7 minus 8 become? Minus 1, isn't it? And guess what we've got? Standard form. Here's your A, just like we saw. There's your A. Here's your H. What's your H? Not 2. Nope. Nope. Opposite sign. Negative 2. What's your K? Negative 1. So we have the vertex. The vertex there is negative 2, negative 1. Write it down. HK, if I could write, is equal to negative 2, negative 1 from here. Okay? We have the vertex. Okay, we also know it's opening up or down. Is it opening up or down? Why? Because what? What do we look at to determine up or downness? The A. And what's your A? Positive. So it's opening up. All right? Now it's opening fast. I mean, it's springing up there really in a hurry, so it's going to be narrow, but it is going to be opening up. The minus 2 minus 1 just tells you where to begin. Okay? So we don't need this anymore. I hope we don't. So let me erase this. All right to erase this? Okay. There goes my smiley face. I'm sad again. Okay. So it says sketch the graph. Based on what we know now that we have it in, and guess what? We've already identified the vertex. There it is. Okay? Done that part. How about the axis of the parabola? Can we identify that? It's always x equal minus 2. Always written as an equation, x equal whatever the h is. X equal minus 2. So there we have the axis. Let me write that over here. X equal minus 2. There's the axis. Here's the vertex. Okay? So, I'm going to erase this one because I don't need it written twice. Okay. Okay. So let's sketch the parabola now. Okay? It's going to be something like this. It's going to be a little messy. We know it's opening up, but I need a little bit of room down here because we got to go left 2, okay, and down 1. And after this, we'll go up. Now, this is going to be a little messy because I have so little room to write. Okay? So first thing we plot is the vertex. Where would it be? Left 2, down 1. There's the vertex right there. Now, while we're there, let's go on and sketch the axis of symmetry. The book always does it in red, so I'm going to do it in red. You get that vertex and go up and down from that. There we have it. There's the axis of symmetry. X equal minus 2. Okay? Now, I'm going to show you how I plot the points. You don't have to do it this way, but I find it easy to do this way. Here's your function right there. Now, it's hiding under the y-axis there, so don't lose it there. I like to find, okay, time out. There's one really easy point always to find in plotting your your parabola. And that's, guess what? The what? Okay, yes. What equals 0? Okay, I said one point that's real easy to determine in graphing your function. And she said 0. I said, what's equal to 0? X equals 0. What is that going to give you? What is the point where x equals 0? The y-intercept. Just like the mx plus b. That b is easy to plot, right? So that's the y-intercept. When you say x equals 0, you get that. Now, guess what? I don't find the standard form particularly easy for that. Go back to the original equation. It's the same equation, right? It's that x equals 0. And when x equals 0, what do you have? What's f of x? What's f of x always in this course? Y. Y equals 7. There's the y-intercept. So go on and plot that. It's so easy to do. So y is equal to 7. There's 1, 2, 3, 4, 5, 6, 7. Y is equal to 7. Y-intercept. 0. So that's 0, negative, 0, positive 7. Okay? See that? Now, don't get up there. Okay. Now, what do we call an axis of symmetry? Whatever that happens on one side of it, the same thing happens on the other. So if we look at that y-intercept, 0, 7, notice it's 2 units away from the axis of symmetry, right? So go 2 more units on the other side. That would be 4. And you can plot the same point here. Get out of there. Okay, the same point there. Okay? So you don't need to do any calculation. Just plot it there. And that point is going to be negative 4, 7. So that'll be a negative 4, 7. Okay? Now, once I plotted my y-intercept, then I come back to this thing. And I like to move one space, and it doesn't matter which way, either to the right or to the left from my vertex. Your vertex is at negative 2. So you want to go one to the right or one to the left. I don't care. Left. Okay, we're going this way. So it'll be a negative 3 here, right? So let's plug in a negative 3. Negative 3 plus 2. Negative 1 squared times 2 minus 1, 1. Okay, so negative 3, 1. That was easy, wasn't it? Yeah. Okay. Now, because of the symmetry, we can go over here to this one and put a 1 there too, right? Opposite side. We've already gone 2 to the left. We've got everything we need to plot this parabola. There it is. Yes, oh, just stretching it. Okay. There it is. Your standard form tells you the vertex. It tells you the axis of symmetry. Your y-intercept is real easy to do. Go and plot that. Because of the axis of symmetry, plot it on the other side. If the axis of symmetry over here, plot it on that side of it. Okay? And then pick one point either side of your axis of symmetry. Either minus 1 will give you 1, then you can plot this one. Or negative 3 gives you this one. Once you get it, plot it there. I mean, axis of symmetry is your friend. Use it, okay? And then you can keep going as many points as you need to get the shape of the curve. It's a pretty easy process to do. Okay? All right. Let's erase my scratch here. And let's see how they did it. Okay? Begin by writing a quadratic function in standard form. That's exactly what we did. Notice the first step in completing the square is to factor out the coefficient of your x squared that is not 1. We had a coefficient of 2, to factor that out of just the x term. Separate that 7 over there. Now, they don't do a good job of that, but here's what they did. They didn't leave a blank like I did. They just separated these two and then factored out the leading coefficient. Okay, that's your A. That gives you x squared plus 4x. Close that off, leave the other things out there. Now, I like to have a blank there because then you can see what you need to do to complete the square. Okay? Now, I don't care for this way to do it, but if you see this better, it's perfectly fine. In completing the square, you look at that, the linear coefficient, 4, take half of it, 2, square that, that's 4. So add 4, but then also subtract 4. Okay? Now, how you got this was half of this squared. That's where that came from. But then you subtract 4. Now, I like to subtract the 8 over here because it just gets in the way there. But if you like it that way, that's fine. They say add and subtract 4 within the parentheses. Okay? Now, after adding or subtracting 4 within the parentheses, you must now regroup the terms to form a perfect square trinomial, which will just be those terms. So then this minus 8 you put over here. So why do 2 steps when you can get by with just 1? But that's up to you. Okay? So the minus 4 can be removed from inside the parentheses. However, because of the 2 out here, that becomes a minus 8. So they take it and put it over here. I just put it there to begin with. Okay? So if you like this way, do it this way. Okay? To me, it's a little confusing, but it is fine. There's your perfect square trinomial. So the next step is just to write down what that is. Okay, here we had it. 2 times your perfect square trinomial minus 8 plus 7. I had plus 7 minus 8. It doesn't matter. Okay? And then we factor that perfect square trinomial. That would be 2 times x plus 2. Again, take half of this. That's a plus 2. Write it here. And that's the square of that. This is the square of this. This is twice the product of those two. So write this in parentheses. Okay? And then combine those, and you get a minus 1. A, H, K. H, K, what's your H? Negative 2. Always the opposite of this one. The K is exactly what that one is. So negative 2, negative 1. And what is that? Your vertex. Your vertex. And that negative H is also your axis of symmetry. X equal negative H. Okay. From that form, you can see that the graph of F is a parabola opening upward because the 2 is positive, has a vertex at negative 2, negative 1, axis of symmetry at x equal negative 2, and you can go from there. This corresponds to a left shift, that's the x minus 2, okay, x plus 2, and a downshift, that's your minus 1. So there's your vertex, plot that, axis of symmetry, plot that, and then that gives you 1 point, and they just throw it in there as if you knew the rest of it. Well, it's not quite fair. Well, I guess what they did was they plotted this one, y is equal to 2x squared, 0, 0, 1, 2, negative 1, 2, 2, 8, you know, they don't show that. But look, if you have the graph, you can already, they don't say this, but from that first form, which they don't show on this screen anymore, you know the y-intercept is plus 7. Let's go ahead and plot that. And then axis of symmetry, plot the 7 over here at a minus 4. So this is 2 away here, 2 away there is here. And then pick another point and plot as many of them as you want to then, and just reflect them across the axis of symmetry. Okay? It's really pretty easy to plot these things. Okay. In the figure, you can see that the axis of the parabola is the vertical line through the vertex, x equal -2. X equal h. Always is that. Always. Once you get the h, you know the axis is symmetry. To find the x-intercept of the graph, then you go back and set that original form, ax squared plus 3x plus c equals 0, just like we used to do with quadratic equations, and find the roots. Factor if you can, quadratic formula if you can. Okay? With x squared plus bx plus c, ax squared plus 3x plus c does not factor, use the quadratic formula. You can find the x-intercept that way. Remember, however, a parabola may not have x-intercepts. When will a parabola not have an x-intercept? What if this had been a -2 plus 1? Then you would come back here 2, come up here, and then it opens up. It never crosses the x-axis. Okay? So you will occasionally have them that do not have x-intercepts. They're always going to have a y-intercept. No matter where. It's got to have a y-intercept. Only one of those. Okay? But it may not have an x-intercept. But if it does, just set that original equation to 0 and do like you always did. Factor or use quadratic formula. Any questions? Okay. Oh my goodness, we are running out of time, aren't we? All right, we'll begin next time with we'll begin next time with example 3. They don't show example 3 in the text, so we will do example 3. Okay? And let me give you a few homework exercises. We came close to finishing, didn't quite get there. Do either 5 or 7 or both. Okay? Do either 9 or 11 or both. Now, all the odds are at calcchat.com. Some of the odds are at CalcView. Number 9's at CalcView. Okay? Do any of the odds 13 to 25? They're all at CalcChat. 17's at CalcView. Okay? And then the rest of those we'll hold off and do a little bit later. Okay? It's 103 in the Ethel Hall building. Ethel Hall building. Okay. Do you know where the dorm is?
Yes, sir.
Okay. And if you
keep straight.
Yeah, if you go past the dorm, it's on the same side of that street as the dorm. There's another couple buildings. One looks like it's being built, and this is where what do they call that? I can't think of what it is, but it's an old house that they've got things in. Keep on going, and a fairly good-sized building is Ethel Hall. It's where the nursing program is. Okay? And it's sort of on the curve. When you walk into it, go through glass doors right there, and then the first thing you see in the office is the main office. You can either go straight down the hall here or take a left and go that way. Take a left and go that way. You go right past the restrooms. First door past the restroom.
What number is it?
103.
103.
Yeah.
Okay.
Okay.
I've been real sick lately.
I'm sorry, I can't.
I've been real sick lately for the past
I'm
2
so
weeks.
sorry.
I've been having head colds, sinus infection. I may want to back up.
Yeah, right.
I just got the flu.
Yeah.
And I just want to know if it's possible to set a test me.
No, it's too late. No, I'm just kidding. Okay. Okay. When would you want to do it?
I don't have school tomorrow. I can probably come up here tomorrow anytime.
Okay, let me give you my office hours tomorrow. If you want to come early, I'm in the office between around 7:45 until, actually tomorrow I'm going to be giving a test for Dr. Thomas. It's going to be right next door. If you want to come around 8 o'clock, I'll be giving a test in that room right over there. It's not going to be 112, and you can come in and take it. Okay? If that's too early for you, I have office hours from 11:15 until 2. So any time in there would be fine. But then after that, I don't have much time. Are you ever on the Birmingham campus? No, okay. Don't say I'll be giving it to Fred, who was just up here, at 4 o'clock on the Birmingham campus, Birmingham East campus. But if you're not over there, You want to do it tomorrow, or you want to wait till Thursday? When do you want to do it?
Thursday at the same time.
Okay, Thursday I have 8 o'clock and 9:30 class. Are you free right now? Or do you have
I
another?
have 9:30 class.
You do. Okay. Well then, after that, 10:45, I'm free up until 1:15. So that's my window on Tuesday and Thursday.
Okay.
10:45 to 1:15.
I need to see you Wednesday or Thursday. I'll come one of those days.
Okay.
Between those times.
Okay. Okay. And Wednesday, remember, is either 8 o'clock or 11:15.
Okay. Thursday, 11:15 too, right?
No, 10:45
10:45.
up until 1:15. Yeah.
I was just wondering if there's any way I can see the test before Friday. Like if I
Say
can,
this
I was wondering if there's any way I can come by like your office or something, maybe and see the test before Friday because I'm going to tutor on Friday.
Sure.
Okay.
Yeah. Now I can't give it to you, but
Yeah,
I
I
can
just
let you
wanted to
see
see
it.
it.
If you want to see it right now, you can look at
Yes,
it.
sir. I
Okay.
just want to see which ones I need to work on. Because I got to go all the way to 125, so I need to make
What's
sure
that?
I got to go all the way to Math 125. I want to make sure I'm
Okay.
getting it all.
Did well.
I forgot my book.
No, you can't. Once you're gone, it's mine. Okay.
I don't have to nobody to steal it.
Okay.
Yeah. They'll steal your book if somebody leave you there like that last semester. Yep. Can I look at my test?
What's that?
Test.
What about it?
Oh, look at
Okay.
Oh, I'm out of shape.
Me too.
Oh, Lord.
Let me shut it right there.
See what I miss.
Good score.
Oh, Lord. I'm tired. Ooh. Let me see what I missed. Probably missed that. Oh, okay, did. Ooh. Ooh. I'm out of breath.
All right.
Thank you.
Uh-huh.
I couldn't say it was a good weekend, but I forgot it was too.
Oh, yeah, we'll have more of week first. Good week. Good week.